Okay, today we're going to talk about 7.2, and in 7.2 this is dealing with the first part of what they in the book refer to as the FOIL method. So we're going to talk about it in two different ways. We've learned how to distribute, and the FOIL method is just a glorified way of distributing. So FOIL stands for first, outer, inner, and last. And what that is that is a description or an acronym to help you remember how to multiply these. So let's take x minus 2 times x minus 1 and multiply these. So in the book, they have you write down FOIL at the beginning, and we will fill these in. So let's go through the steps. First means take, basically like distributive property, and multiply x times the x, because that is our first in each of the parentheses. So I will label it with an F. So x times x we know to be x squared. Outer means that I take the first number in the first parenthesis and multiply it times the last one or the back one. So negative 1 times x is negative x. And I'll label it with an O. Inner is going to be the two that are closest to each other, which is the negative 2 and the x. So for my inner, I am going to have negative 2x. And then last is exactly what it sounds like. It's the last two in each grouping multiplied times each other. So negative 2 times negative 1 is positive 2. Now in FOIL, it has a unique ability to combine the O and the I. So I'm going to put a box around the O and the I because you should always check to see if those two can be combined. If they can, then you're going to do it in your final step for your answer. So you recopy the first term, which is x squared. Normally, f, which is your first, is going to have your highest exponent. The only way that is not true is if they do not have them in the correct order. In other words, descending power order. Biggest exponent first, smallest exponent at the end. If they don't have it that way, you might want to rewrite this so that it makes it easier to combine like terms in the end part of the process. So now we have x squared as our first part. We combine O and I. Remember, this is actually negative 1x and negative 2x being combined. So negative 1x and negative 2x makes negative 3x. Then you recopy your last, and that is your final answer. So let's put another one up for an example, and let's make this a little more, a little bigger of a process. So let's say I have 3n minus 4 times n plus 1. Once again, I list my FOIL below. And let's show this. So F is 3n times n, which is going to give me 3n squared. O is going to be the outer two. So the ones furthest from each other, there's my O. So 3n times 1 is 3n. I is going to be the two middle ones, the ones closest to each other. So negative 4 and n make negative 4n. And then L are my furthest two. So for L, you're going to have negative 4 times 1, which gives me negative 4. So once again, I put a box around my middle two, and I check to see if I can combine them. And yes, we can combine them. So 3n and negative 4n we're going to combine. So let's start from the beginning. We put down 3n squared because that is my largest exponent, and nothing can combine with it. 3n and negative 4n is going to be negative 1n. And then we recopy the back, which is going to be negative 4, which is my last. So this is my final answer, 3n squared minus 1n or n minus 4. Let's do this now. Instead of FOIL, let's do this as the distributive property. So in distributive property, you're going to find it to be very similar to FOIL, only instead of using the word FOIL, they say distribute. So in this case, we have r plus 3 times 3r plus 2. So in distributive property, we take the r times each of them. So we kind of make the same symbols. So r times 3r is 3r squared. R times 2 is plus 2r. 3 times 3r is plus 9r. And then 3 times 2 is going to be plus 6. Now, if these are wrote from least to greatest in the original groupings, then they should come out as the biggest exponent being your first one, and then so forth going down in order. If you notice, once again, the middle two are going to combine in this case. So 3r squared plus 11r plus 6. That is my final answer. As you notice, both of them have about the same amount of work, so neither one of them is more of an advantage. Let's do one more distributive property, and then I will show you the third method, which is called the rectangle method. Some call it the table method, some call it Mendelssohn's theory. Just depends on who you talk to. So 2a plus 5 and a minus 1. Once again, we're going to use the distributive property. So 2a times a is 2a squared. 2a times negative 1 is negative 2a. 5 times a is going to give me 5a. And 5 times negative 1 gives me negative 1. Once again, they were already written from least to, greatest to least, so therefore the middle two are going to combine, and it gives me 2a squared plus 3a minus 1. The last process we're going to talk about today is going to be the rectangle method, or as like I said, some call it the table method. So in this particular method, what we're going to do is once again line them up. So x plus 3 and x plus 2. I have two terms in this one and two terms in this one. So we're going to make a table, a 2x2 table. So 2 columns, 2 rows. I normally put the smaller of the two to the left and the bigger one on the top. Since they're the same amount, it does not matter which one you put first. Now, when you do this, the only signs you're going to write in the outside is going to be if it's a negative. And in this case, it's all positive, so you write them without signs. So to get into the rectangle, you multiply. So x times x is x squared. X times 2 is 2x. So forth on the bottom. 3 times x is 3x, and 3 times 2 is 6. Now, the reason why there's an advantage to this is you can go back and check your multiplication really quickly. However, it also lines up what ones you need to combine automatically. So if you have it in descending power order correctly in both groupings and you rewrite it that way, the diagonals will always need to be added. If you notice, the very first one has no one to combine with. The middle two will combine, so they're both positive, so I have 5x. And then the end has nobody to combine with, which makes 6. So you multiply to get in, and you add the diagonals to get out. Remember, when you add diagonals, you do not change the exponents. Only when you multiply do you change the exponents to get them in. Let's do one more, a little more complicated. So let's say I have 6h minus 2, and I have negative 3 minus 2h. In this particular one, we have to do a little bit of fixing in this. So the first thing I'm going to do is draw my rectangle. It is a 2x2 again, because I have 2 terms in the first one and 2 terms in the second one. If you notice in the first one, we already have it as 6h, and we put the negative with the 2, so we remember to carry the sign. In the second grouping, we have an issue. We need to take and put the negative through. So I need to rewrite it as negative 2h and negative 3. Multiplying it in gives me negative 12h squared, negative 18h, positive 4h, and positive 6. Remember, we add the angles or the diagonals, and it gives me negative 12h squared minus 14h plus 6. And this is the end of the third method, which is called the rectangle method. If you have more questions, go to our textbook and look at 7.2. Thank you.